In this video, we are going to compute a double integral, but before that, we have to set it up to compute the volume of a solid bounded by the xy plane. The surfaces y equals 0, y equals x, and x equals 2, and the paraboloid z equals x squared plus y squared. So this is a lot of stuff, and it seems like really hard, but here is the first thing you need to do is think about what is your bottom surface, what is your top surface. So usually this would be like z equals something. So you can see that you have z equals x squared plus y squared, but also they tell you the xy plane. And the xy plane has an equation z equals 0, right? So likely what's going to happen is this is going to be your bottom surface, z equals 0, and then the top surface is going to be z equals x squared plus y squared. Now, I also want you to look at the picture here because it's always easier to look at the picture, right, to visualize the situation. So this is the solid. So you can see on the bottom is bounded by the xy plane, which is z equals 0. And on the top, you can see that that's your paraboloid, right? That this paraboloid right there, okay? Now, what about the let me just try to rotate it so you can see the projection of the solid onto the xy plane. So you can see that that's a triangle, right? And this triangle, where does it come from? Well, they tell you y equals x, right? They gave you these limits. They said y equals 0, y equals x, x equals 2. What does that look like? So this is the triangle right there, right? So y equals 0 is what? That's the axis, right? Y equals x is the 45-degree line. And then x equals 2 is a vertical line. So you can see that that triangle is the projection of the surface onto the xy plane. So again, the inside limits should be bottom surface to the top surface, which is x squared plus y squared. Now, these two is the limits over the projection to the xy plane. How do we set up the limits over this triangle? So remember that the outside limits are extreme values of x, if you think about it as a type 1 region. So this is going to be 0 to 2, right? That's going to be the outside limits. Those are the x limits. The inside ones is going to be the bottom curve to the top curve. Now, what is the bottom curve? Let's look at this. So the bottom curve is that y equals 0, right, which is the x-axis, and the top is y equals x. So this should be 0 to x. Okay, now that we set this up, we are going to also think about, okay, what are we trying to integrate here? Now, if we are evaluating the volume using triple integrals, then you are evaluating 1. Okay, that's your integrand. Just like if you were talking about double integrals, and if you are integrating 1 and over some kind of region, you are really finding the area of the region. Same thing here. When you are evaluating a triple integral and you want to evaluate the volume, you are evaluating 1. Also note that this answer must be positive, because if it is not, then how could that be volume? So hopefully that is going to be positive, but let us go ahead and compute it. Okay, so let's go 0 to 2, and then 0 to x, and then 0x squared plus y squared, and then this is just 1 dz dy dx. Okay, and again, what is this? This is the bottom surface, z equals 0. This is the top surface, x squared plus y squared. And then these limits came from the projection over this thing on the xy plane, which is the triangle, as we had the picture there, but I just want to draw it again so that you can see it. This is y equals x. This is x equals 2 right here. And so you are integrating over this thing. Right? These limits are just like double integrals. If you know the projection, these limits are just double integral limits. Okay, let's evaluate the inside integral first. So that's going to be integrating 1 with respect to z. So that's just going to be when you integrate a constant, you multiply it by the variable with respect to which you are integrating. So this is going to be 1 multiplied by z, which is just going to be z. Okay, and then we substitute z equals 0, z equals x squared plus y squared. So this is very important that we put z equals, because generally, since now you have 3 different variables, who knows which one are you substituting for, so you got to be careful there. In this case, it's just z, so it was kind of clear, but still, I mean, if this was like x, whatever, then z would stay z. Okay, so anyway, we will substitute in x squared plus y squared first. That's the top limit. Minus z equals 0, which is 0. Okay, so that's it. And then we are integrating dy dx. So now we are down to just a double integral. So let's integrate it inside with respect to y. So when you integrate in x squared, don't make a mistake to think that you need to integrate x cubed over 3 or something like that, because this is with respect to y, right? And when it's with respect to y, this thing is just a number. So integrating a number means multiplying by the variable with respect to which you're integrating, which in this case is y. So that's going to be it. Plus, now y squared integration with respect to y is the normal integration. So that when you add 1 to the power, you get y cubed. And then 1/3 comes out in the front. Okay, now we substitute y equals 0, y equals x, and then this is dx. Okay, so what do we get? We get, again, it's important to put which variable you're substituting for, right? Okay, so we are taking y as equal x, and we're substituting it for y and leaving the other one the same. So it's going to be x squared times x plus 1/3 x cubed. Now, substituting 0, which you should substitute next, just gives you 0 when you substitute it for y. So that's just going to drop out. And let's see if we can always try to simplify the expression before you move on and start integrating. We do have like terms here, okay? And those are x cubed. So we got x cubed plus 1/3, that's 4/3 x cubed. And now we are ready to integrate for the last time. So this is going to be 4/3, add 1 to the power, and 1/4 comes in the front. So this 4 will cancel, and we substitute in 0 to 2. So 2 to the power 4 is 16/3 is what I got. Let's see if that is correct. Let's test it out.